Now this question is a solubility question, obviously, and we're given some information that the solubility constant for thallium sulfide. So if we're being asked about that, then and it's 6 times 10 to the negative 22nd, and we're then also told that the hydrogen sulfide ion has a pKa of 11.96. So it's getting this information straight in your mind initially, but we're asked to calculate the solubility and then discuss how changing the pH by addition of an acid or base is going to affect it. Now, calculating the solubility is relatively straightforward. If we're dealing with thallium sulfide, so we can actually write out a simple equation just to reiterate what calculation we should proceed with. And I know it's Ti plus, we're told it's thallium 1 in this equation, that's up there, and that means Ks equals 4s cubed. So all we have to do for this then is for 6 times 10 to negative 22 is divide that by 4 and take the cube root of that, and that should 5.31 times 10 to the negative 10 moles per litre. Oh, negative 8, sorry. And so we've worked out solubility. Now we're asked to talk about how changing the pH of the solution by addition of an acid or base affects that solubility. Now there's some information to help us. Now before we look at this equation, which is just the one for thallium sulfide, now before we get started on this, we need to have a look. I mean, obviously we're interested in what happens to equilibrium involving thallium sulfide and water as we change the pH, but if we look at hydrogen sulfide and water, it makes a conjugate base on that side. We have a fairly weak acid, so we'll have a conjugate base which isn't that strong, it's relatively weak. And when we add acid to this, and the reason that's important is if we know what this is up here, we know how it's going to respond if we add an acid or a base. Therefore we have another equilibrium going on there which we need to consider, that we've got the equilibrium with thallium sulfide with water, which produces thallium ion and sulfide ion, and the sulfide ion itself dissociates in water to produce hydrogen sulfide and hydroxide ions to a small degree. So if we add acid to start with, what's going to happen here? If we add acid, obviously that's going to remove some of the hydroxide ions, it's going to decrease that. That means that this equilibrium will shift over to the right, and that's going to use up some of that. So when we do that, that's going to increase the solubility, and so more thallium sulfide will be able to dissolve. So as we decrease the pH, the solubility should increase because we're removing some of the hydroxide ions, so the sulfide ions move across, and that means the solubility will increase. Now if we add hydroxide ions to the situation, what's going to happen there? If we have more of these, that means that's going to have the equilibrium shift over to that side and produce more sulfide ions. And if we produce more sulfide ions, that's going to decrease the solubility, and that means that equilibrium will shift over that way, and we'll have less thallium sulfide being able to actually dissolve. So as we make the pH more basic, we get a decrease in solubility. Okay, so that's really all you have to discuss in that question.